Okay, first of all, the first question is an example of how we can solve the three variable system. So the essence is to convert the three variable system to a two variable system and use a method to solve two variable system to solve the rest of the question. Okay, if you're not very familiar with this, you can refer to the example I give you here after this class. And actually, we have practiced this once in our previous assignment. Okay, if you are still not very familiar with this, listen carefully in this class. Okay, I'm gonna show you how to solve a three variable system of equations. Okay, let's start from question 1. Okay, question 1 is a typical two variable system. So how do we solve this? You can either use elimination or substitution, right? So here, it's easy to use substitution from, okay, let's label this with 1 and this with 2. So from equation 1, we can solve that y equals 7, sorry, y equals 3x minus 7, right? And let's label this with 3. And then we can put 3 into equation 2. In this way, you will get 2x plus 3y. 3y means 3 times 3x minus 7 because y is 3x minus 7, right? Okay, so left hand side equals 1. And then you get a one variable, one equation. So from here, you can solve the value of x. Okay, so this gives you 2x plus 9x minus 3 by 7 is 21, right? Okay, then from here, you can get 11x equals 22. So what is x here? Of course, x is 2, right? Okay, so you know that x is 2. Let's label this with number 4. Then we can put number 4 into either equation 1 or equation 2 or equation 3. So 3 makes easier. So let's put it into 3. Then you will get y equals 3x. That means 3 times 2 minus 7, right? Okay, so y is minus 1. So our final solution is x equals 2 and y equals minus 1. So as usual, I strongly suggest you that put this result back into the equation to verify your result, okay? So each time you finish the solution, please double check your result. If you make mistake there, the original equation can't hold with your solution, okay? Please do verify your solution. All right, any questions? Oh, all right, let's see the next one. Question 2. 5x plus 4y equals 1. At the same time, 3x minus 6y is 2. So again, you can either use elimination method or substitution method, right? If we use substitution method here, for example, we can, from equation 1, we can solve x in terms of y, or solve y in terms of x, right? In that way, we'll introduce ratios. So usually I don't like that. So let's try elimination method. Okay, how do we eliminate x or y? Note that we can eliminate y. Y seems easier, right? So let's find the least common multiple of 4 and 6. Of course, that's 12, right? So we need to time a 3 to both sides. Time a 3 to both sides of equation 1. Then you will get 15x plus 12y equals 1, right? So let's label this with 3. And then you need to time a 2 to both sides of equation 2, right? And from there you will get 6x minus 12y equals 4. Sorry, this is 3 here. So let's label this with 4. So how do we eliminate y? We can simply use 3 plus 4, right? Equation 3 plus equation 4, you will get 15x plus 12y, left-hand side of the first equation, plus 6x minus 12y, the left-hand side of the second equation, equals 3 plus 4. So let's simplify this. You will get 21x equals 7. Okay, that means x equals 1 over 3, right? So let's label this with 5. Then you can put 5 back into equation 1 or equation 2. So let's put it into 1. Then you will get 5 times 1/3 plus 4y equals 1, right? And from here you can solve 4y equals minus 2 over 3. And y is minus 1/6. So the final solution is x is 1 over 3 and y is minus 1/6. Okay, any questions? Have a look at this. No questions? All right, let's see the next one. Okay, next one, again, we can use either elimination or substitution, right? So note that 6x is actually 3 by 2x, right? So we have a 2x here. So actually, it's easier to use substitution, right? We can substitute 2x with minus 10 minus 4y, right? Okay, so following this, let's label this 1 and 2. Okay, from 1 we can get 2x equals minus 10 minus 4y, right? Of course, you can solve x, which is minus 5 minus 2y. Or it's not necessarily for you to solve it. You can just leave it there because you can just put 2x in the second equation, right? So let's call this number 3. Then we can put number 3 into 2. Then you will get 6x is 3 by 2x. 2x is minus 10 minus 4y. right? Plus 3y equals 6. So here you will get only one variable and one equation. From here you can solve y. So let's divide both sides with a 3. Then you will get actually minus 10 minus 4y plus y equals 2, right? Okay, and from here you will get minus 4y plus y is minus 3y equals, if you put minus 10 to the other side of the equation, it becomes plus 10. So 2 plus 10 is 12. And of course, y is minus 4, right? Because 12 divided by minus 3 is minus 4. So let's call this number 4. Then we can put number 4 back into number 3. You will get 2x equals minus 10 minus 4 times minus 4. So x is 6 over 2, which is 3, right? Okay, so now we can make the conclusion. X is 3 and y is minus 4. This is our solution. And of course, you need to put them back into the original equation to verify your answer here. All right? Okay, have a look at this. Any questions? Please let me know. Okay, any questions? No? Okay, let's see the next one. Next one seems easier to use substitution method, right? So from equation 1, we can solve x in terms of y. X is actually 6 plus y, right? So let's label this with 3. Then we can put 3 into 2. And then you will get minus 2 times 6 plus y plus 2y equals 1, right? And let's expand it. Minus 12 minus 2y plus 2y equals 1. Okay, and then minus 2y plus 2y gives you 0 times y, right? And let's put minus 12 to the other side of the equation. Then you will get 13, right? So 0 times a number equals 13. Which is this? What is this number? Of course, this number does not exist, right? So here we know that there is no solution to the original system. No solution. Okay, so there's no solution for y. Of course, there's no solution for x. So there's no solution for the original system of equations. Okay, have a look at this. Any questions? Okay, so now the takeaways is sometimes you will get exact solutions, such as what we get in the previous question. Sometimes you will get no solution, right? And sometimes there are infinite number of solutions. Okay, each of them is possible. All right, any questions? No? All right, let's see question 5. Okay, question 5. It's not obvious that we can eliminate R or S, right? So I think it's better to use substitution method. So let's solve R in terms of S or solve S in terms of R. Okay, for example, from equation 1, we can solve R in terms of S. Okay, let's time a 6 to eliminate all the denominators. So time 6 to both sides of equation 1. And this will give you 4R plus 5S equals 33, right? And now we need to solve R in terms of S. So R equals 33 minus 5S over 4. And then let's call this 3. Then we can put 3 into number 2, right? Do not put it back into number 1 because it's derived from number 1. You can't put it back. If you put it back, of course, number 1 will hold, right? That will not help you to solve this question. So let's put number 3 into number 2 because we haven't used number 2 yet, right? So let's put 3 into 2. And this will give you 2s over 3 equals 7 over 3 plus 1/2 times r. R is 33 minus 5s over 4, right? Okay, so how do you solve s here? So let's eliminate all the denominators. So we can time a 24 to both sides of the equation. Here we'll get 2s times 8 equals 7 times 8 plus 3 times 33 minus 5s, right? Okay, then you will get 16s equals 56 plus 99 minus 15s. Then let's put minus 15s to the left-hand side of the equation. It becomes 31s equals 56 plus 99 is 155, right? Okay, so S is 155 over 31. It happened that 155 can be divisible by 31, which you will get a 5. So S is 5. So let's call this number 4. Then you can put number 4 back into number 3, right? Then you will get R is 33 minus 5 times S. S is 5 over 4. That means 33 minus 25 gives you 8. 8 over 4 gives you 2, right? So in this way, we have solved S and R. So the final solution is R is 2, S is 5, right? Okay, have a look at this. Any questions? No questions? All right, let's see question 6. Okay, again, you can choose either elimination or substitution. So here I'll show you the substitution method. From equation 1, we can solve x or solve y in terms of the other variable, right? So note that we don't like denominators here. So usually I will time a 5 to both sides of equation 1. Then this gives you 3x minus 4y equals how many? 15, right? Okay, from here you can actually solve x in terms of y. Okay, this time let's solve y in terms of x. So 4y equals 3x minus 15. So y equals 3x minus 15 over 4, right? So let's call this 3. Then let's put 3 back into 2. Number 2. Because we haven't used number 2 yet, right? So let's put number 3 into number 2. Then you will get 8y. So y is 3x minus 15 over 4. Minus 6x equals 5. Now the thing becomes good here because we only have one variable and one equation, and we know how to solve this, right? Okay, so by distributive law, 8 times something over 4, you can cancel a 4 here. This gives you a 2. Twice of 3x minus 15 minus 6x equals 5. And let's expand this. That means 6x minus 30 minus 6x equals 5, right? Okay, that means 6x minus 6x means 0x, right? And if you put minus 30 to the other side of the equation, it becomes positive 30. So positive 35. Okay, that means 0 times something equals 35. Does this number exist? The answer is no, right? So there is no solution for x. No solution for x means there is no solution for y, of course. So you can make the conclusion. No solution. Okay, do you see the logic here? Okay, that means no matter what value x is, this equation cannot hold, right? Okay, have a look at this. Any questions? Please let me know. No questions? Okay, let's see number 7. Okay, number 7, note that the second equation is not in its simplest form, right? So let's simplify the system first. Okay, first equation, we can eliminate all the denominators by timing a 6 to both sides of the equation, right? So that will give you 2r minus s equals 3, right? And for the second equation, let's simplify this. R minus 6r gives you minus 5r and plus 5s equals 14 minus 4 equals 10, right? So the original system is equivalent to the new system here. This looks neater, right? Okay, so let's call this 1 and call this 2. And from 1, we can solve S in terms of R. S is actually 2R minus 3, right? Okay, let's call this 3. And then we can put 3 into the other equation, which is 2, right? And this will give you minus 5R plus 5S. S is 2R minus 3 equals 10, right? Okay, let's continue here. Okay, that means minus 5R plus 10R minus 15 equals 10, right? And this means 10R minus 5R gives you 5R equals 10 plus 15, right? Remember that if you put this number into the right-hand side of the equation, the positive sign becomes negative sign. Negative sign becomes positive sign, right? So 10 plus 15, that means 25. So R is 5, right? So let's call this number 4. Then we can put number 4 into number 3 to solve S. Okay, S is 2R minus 3. That means 2 times of 5 minus 3, which is 7. So now we can make the conclusion. Our solution is R equals 5 and S equals 7. Okay, and please do put the result here back into the original system to verify your solution. Okay, please have a look at this. Any questions? Let me know. Okay, no questions? Let's see the next one. Next one. Again, you can use either elimination method or substitution method, right? Okay, let's see equation 1 and equation 2. Equation 1 is not very linear, right? So let's see if we can convert it to linear equations. So note that y cannot be 0, right? Because if y is 0, it is not a solution to the first equation because y is denominator. Denominators cannot be 0. So because y is not 0, so we can time a y to both sides of the first equation to both sides of 1. And this will give you x minus 3y equals 2, right? This is a linear equation now. So let's call this 3. It's not over yet. Okay, from here we can solve x is 3y plus 2, right? Okay, let's call this number 3. So we can put number 3 into number 2, right? And this will give you twice of x, means twice of 3y plus 2, minus 9y equals minus 8. And from here we can solve the y. It will get 6y plus 4 minus 9y equals minus 8, right? Okay, that means minus 3y equals minus 12, right? Because minus 8, when you put the positive 4 to the other side of the equation, you will get minus 4. Minus 4 minus 3 is minus 12. So here we know that y is 4. Okay, let's call this 4. Put number 4 into number 3, you will get x, right? X is 3 times of y, means 3 times of 4 plus 2, which is 14, correct? So now we can make the conclusion. X is 14 and y is 4. This is our solution. And again, do not forget to verify your solution by putting them back. All right, any questions? No questions? All right, let's see number 9. Okay, note that the second equation is not the simplest one, right? So it's better to simplify the second equation first. And at the same time, if you don't like decimals here, you can convert the first equation to convert the decimals to integer coefficients. So let's do this. First equation, you can time a 2 to both sides of the equation, right? If you time a 2, minus 2.5 becomes minus 5 plus 10b equals 50, right? Of course, if you can't see the multiplier of 2, you can always time a 10, right? If you time a 10 to both sides of the equation, you will get this one, right? Which is doable, but seems not necessary because you can then cancel a 25 to both sides of the equation. Then you will get this one, right? So it's better to time a 2 actually. Okay, how about the second one? Second one, you will get 3.75a minus 6b, right? Equals 42 minus 15 is 27. Okay, then we can further simplify this. First equation, you can divide a 5 to both sides of the equation. This will give you, okay, let's do this. Equation 1, equation 2. Okay, from the first equation, you can actually time a 1/5 to both sides of equation 1. And this will give you minus a plus 2b equals a 10, right? Okay, that means you can solve a in terms of b. A is 2b minus 10. So let's call this 3. And then you can actually put 3 into equation 2, right? And this will give you 3.75a. A means 2b minus 10 plus 6b equals 27. Okay, let's expand everything there. 3.75 times 2b is 7.5b, right? Minus 37.5 minus 6b equals 27. Okay, this gives you minus 1.5b equals 27 plus 37.5 is 64.5, right? Okay, and then you can solve b. B is 645 over 15, which is 443, right? Okay, then let's label this with 4. Then we can put 4 into 3 to solve our a here. A is twice of b, means twice of 43 minus 10. This will give you 86 minus 10, which is 76, right? Okay, so now we can make the conclusion. A is 76, B is 43. This is our final solution. Okay. Do you have any questions? If you don't, please, if you have done this incorrectly, please try to fix this by yourself, okay? All right, if you don't have any questions, let's look at next one. Okay, next one, note that we can directly solve x in terms of y from the second equation, right? So from the second equation, we can solve x equals minus 0.4y minus 3.6. So let's label this with 3. Then we can put 3 into 1. And this will give you 0.5 x means 0.5 times minus 0.4y minus 3.6, right? And minus 3.5y equals minus 5.5. So let's expand everything there. This is 0.2. Y minus 1.8 minus 3.5 y equals minus 5.5, right? Okay, let's continue here. And this will give you 3.7 y equals 5.5 minus 1.8, right? Which is 3.7. So that means y equals 1. Okay, let's call this number 4. Then we can put 4 into 3 to solve our x there. So that means x equals minus 0.4 times 1 minus 3.6, which is minus 4, right? Okay, so the final solution is x is minus 4, y is 1. All right, any questions? No? Okay, let's see the next one. Question 11. Again, the methods are very similar to what we have used in previous question. So from equation number 2, we can directly solve x in terms of y. X is 0.5y minus 0.75, right? So pay attention to the signs here. Do not confuse the positive sign with negative sign. Otherwise, you will make mistakes in the very first step. So let's call this number 3. Then we can put number 3 into number 1. This will give you 0.875x. X is 0.5 y minus 0.75. And then minus y, right? Equals minus 0.5. So note that 0.875 is actually 7/8, right? Okay, let's convert this into ratios. That will make things easier. Times 1/2 of y minus 0.75 is actually 3/4, right? Okay, minus 5 equals, this is actually minus 3/2. Okay, then how do we solve this? Okay, there's no better way, right? So let's expand everything. 7/16y minus 32, and then minus y equals minus 3/2. Then let's put all the y's to the right hand side. This gives you 9/16y equals 9/16y equals 3/2 plus minus 21 over 32, which is 32 as a denominator, and then 3 by 16 minus 21. Okay, which is 48 minus 21, which gives you 27. 27 over 39, right? Okay, so 9 over 16 times y equals 27 over 32. Y is 27 over 32 times 16 over 9, right? So by simplification, we know that y is 3 over 2. Let's call this number 4. Then we can put number 4 into number 3 to solve for x. Sorry, x is 0.5 times 3 over 2 minus 0.75. Okay, which is 0, right? This is actually 0. So now we can make the conclusion. X is 0 and y is 3 over 2. This is our solution. Okay, please have a look at this. Any questions? No? Can you follow me? Okay, let's see the next one. All right, next one. Note that from the first equation, we can solve y in terms of x, right? Okay, let's do this. From the first equation, we can solve y actually equals 1.x minus 1.6, right? Okay, let's call this number 3. Then we can put number 3 into equation number 2. Then you will get minus 3x plus 0.5y. Y is 1.2x minus 1.6. And this equals 0, right? Okay, and from here we can solve x. Okay, this means minus 3x plus 0.6x minus 0.8 equals 0. Okay, and let's put all the x's to the other side of the equation, and this will give you 2.4x equals minus 0.8, right? Okay, that means x is 1 minus 1 over 3, right? Okay, let's call this number 4. Then we can put number 4 into number 3 to solve our y there. Y is 1.2x. X is minus 1 over 3. Minus 1.6. So that means y is -2. Okay, so the final result is x equals -1/3 and y equals -2. Okay, any questions? No questions? Okay, let's see the next one. Okay, questions 13, 14. The systems with 3 variables, right? As I said, when you have 3 variables, you need to reduce the number of variables to 2 variables. And from there, you can use the same method we use to solve the 2 variable linear systems. Okay, following this concept, how do we eliminate one of the variables there? You can solve one of the variables in terms of the other 2, right? Okay, for example, from equation 1, we can solve x is actually 2y minus 3z plus 7, right? This is called solving x in terms of y and z. Okay, I'll write it here. Solving x in terms of y and z. Of course, you can also solve y in terms of x, z, or solve z in terms of x and y, right? The reason why I solve x in terms of y and z here is in this way, you won't introduce any ratios, right? And the problem seems a little easier for you. So let's call this number 4. Then you can put number 4 into the other 2 equations, right? So if you put number 4 into 2 or and 3, what will happen there? You will eliminate x there, right? Because here x can be described by y and z. If you put 4 into equation 2 and 3, you will eliminate x there. In this way, you will get 2 variable systems. So let's do this. Put 4 into 2. If you put equation 4 into 2, what you will get? You will get twice of x. That means twice of 2y minus 3z plus 7, right? Plus y plus z equals 4. And then further simplified to 4y plus y is 5y. And minus 6z plus z gives you minus 5z. 2 by 7 is 14, right? So if you put 14 to the other side, you will get minus 10, right? In this way, you will get an equation with only 2 variables. So Let's call this number 5. Okay, using the same way, of course, we can put number 4 into 3, right? And if you put 4 into 3, what you will get there? You will get minus 3 times x. X is 2y minus 3z plus 7, right? And plus 2y and minus 2z. Just copy the rest of the terms. Okay, let's simplify. Then minus 6y plus 2y is minus 4y. And minus 3 is 9z. 9z minus 2z is 7z. Okay, and equals minus 21. To the other side, 21 minus 10 is 11, right? Okay, then you will get number 5 and number 6. Actually, the system becomes 5y minus 5z equals 10, right? And minus 5y plus 7z equals 11, right? The original system becomes the new system here. And this is actually equivalent to the original system. And from here, you already know how to solve this, right? You know how to solve this because this is a 2-variable, 2-equation system. We have solved a lot of these questions, right? Okay, so how do we solve it? Okay, from number 5, we know that we can solve y in terms of z. Okay, this means y minus z equals minus 2. And this gives you y equals z minus 2, right? Okay, let's call this number 7. And then we can put number 7 back into number 6. Why do you need to put 7 into 6? Because in that way you can eliminate y and solve that, right? Okay, this will give you minus 4y. That means minus 4 times z minus 2, right? And plus 7z equals 11. Okay, and in this way you can see there is only one variable there. Okay, that means minus 4z plus 8 plus 7z equals 11. So what is that here? 4z equals 3. Sorry, 3z equals 3. That means z equals 1, right? Okay, let's write it here. That is 1. So it's good that we have solved for that. Then how do we solve the other 2 variables? Note that you can put number 8 into number 7 here to solve for y, right? Okay, so let's put 8 into 7. This means y equals z, which is 1 minus 2, which is minus y. This is our y, right? Okay, let's call this number 9. And we now only have one variable to solve, which is x. So how do we do that? We can put 8 and 9 into the 4 here, right? Into equation 4, because equation 4 tells you x in terms of y and z. If you put the values of y and z there, you will get the value of x, of course. Okay, so this will give you x is twice of y means twice of -1 minus 3 times z. Z is 1. And plus 7. So the value of x is 2, right? Okay, now we can make the final conclusion. X is 2, y is -1, and z is 1 is our final solution. Okay, have a look at this. Any questions? Okay, if you haven't done this right, this is time you correct it by yourself. Okay, try to correct it by yourself. If you have encountered any questions, please let me know here. All right, if you haven't finished, do this after this class, okay? I'll show you the next one. Okay, next one, we'll use the same method. Okay, let's label them with equation 1, 2, 3. Okay, so from 1, 2, or 3, we need to eliminate the number of variables, right? And it's easier to start from equation 2 because from equation 2 you can easily solve y in terms of y, x, and z, right? So equation 2 tells you y equals 4x plus 5, right? So you don't see that here. Doesn't matter. You can still put number 4 back into the other two equations, and it will give you a two variable, two equation system. So here, let's put equation 4 into 1. Then you will get twice of x minus 4y. Y is actually 4x plus 5, right? Okay, and then plus 5z equals minus 33. Okay, let's simplify this. 2x minus 16x is minus 14x. And minus 20 plus 5z equals minus 33. Okay, further simplified to minus 14x plus 5z equals minus 13, right? Okay, let's label this with 5. Okay, again, let's put number 4 into Okay, this time let's put it into 3 because we haven't used 3 yet, right? Okay, if you put it into 3, you will get minus 2x plus 2y means plus 2 times 4x plus 5. And minus 3 that equals 19. Okay, let's simplify this to 6x plus 10 minus 3z equals 19. Okay, and this is actually 6x minus 3z equals 9. Okay, let's label this with number 6. Actually, you can further simplify this by divide both sides using 3, right? And this will give you 2x minus z equals 3. Okay, then from number 6, you can solve that is actually 2x minus 3, right? Let's call this 7. Then you can put number 7 into number 5, right? And in this way, you will get minus 14x plus 4z. That means 4 times 2x minus z equals minus 13. So let's simplify this. This means minus 4x equals 2. Correct? So of course here we can solve x is minus 1/2. So let's call this 8. Okay, and then you can put 8 back into 7, where you can see you can solve that is twice of x means twice of minus 1/2 minus 3, which is minus 4. Okay, and then let's label this with 9. And then to solve the other variable, which is y, we can put number 8 and number 9 back into number 4, right? And this will give you y is 4x plus 5. So there's no that, so you don't have to put number 9 there. All you need to do is to plug number 9 back into number 4, which you will get y equals 4 times x. X is minus 1/2 plus 5. This will give you y is actually 3, right? Okay, so final conclusion. X is minus 1/2, y is 3, and z is minus 4. This is our final solution. Okay, please have a look at that. If you haven't done this correctly, this is a time for you to correct it by yourself. Okay, any questions, please do let me know. Any questions? No? Okay, if you haven't done this yet, please correct this by yourself after the class, okay? All right, let's see the next one. Okay, next one. It's not a linear system, right? Because there are square roots there. So we can use substitution method to convert it to a linear system. Okay, so we can let square root of x equals m and square root of y equals n. Then the original equation becomes 1/3 of m plus 2/3 of n equals 1. And m plus 1/2 of n equals 0, right? Okay, so this equals, first equation we can times 3 to both sides. This means m plus 2n equals 3. And next one, m plus 1/2 of n equals 0. So let's label this with 1 and 2. And then we can use 1 minus 2. And this will give you 3/2 of n equals 3, right? So n is 2. Okay, let's call this 3. And we can then put 3 back into 1. This means m plus 2 by 2 is 4 equals 3, right? And then you can solve m is minus 1. So n is 2 means square root of y is 2. That means y is 4. So m is minus 1 means square root of x is minus 1. So that means there is no solution for x, because the square root of nothing equals minus 1 in the real number set, right? We don't consider the complex number here yet. So in the real number set, there is no solution for x. So the final conclusion is there is no solution for this system in the real number set. Okay, any questions? No? Okay, let's see question 16. Okay, again, it seems that this is not a linear system, right? So first of all, we need to convert this into a linear system of equations. So we can use 1 over x equals m and 1 over y equals n. So the original system is equivalent to m plus 1.5 n equals 10 and 1.75 m plus 0.5 n equals 13.25. Okay. All right. Next, let's label this with 1 and 2. Okay, from 2, we can solve n. 0.5 n equals 13.25 minus 1.75 m. And then we can solve n, right? But you don't have to solve n there. You can leave the coefficient here because 1.5 is 3 times of 0.5. So just leave it there and put it back into number 1. So let's label this with 3. Next, we can put 3 into equation 1, and this will give you m plus 1.5n. Why 1.5n means 3 times 0.5n, right? Equals 10. So that means m plus 3 times 13.25 minus 1.75 m equals 10, right? Okay, then we can solve for m here. M plus 39.75 minus 5. How much is here? Okay, 5.25 m. Equals 10, right? Okay, then you will get 4.25 m equals 29.75. Okay, so this means m equals 2975 over 425, which is 7, right? Okay, so let's call this number 4. Then we can put number 4 into 3. Then you will get 0.5n equals 0.25 times 1.75 times 7. And this is okay, let's calculate this. Is 1, right? Okay, so that means n is 2. So n is 2. Okay, so that means 1 over x is 7 and 1 over y is 2. Of course, the final solution is x is 1 over 7 and y is 1 over 2, right? Okay, any questions? No? Okay, let's see. Question 2. Suppose that x equals 5t minus 6 and y equals 9 minus 15t. Find y in terms of x. Okay, so in order to find y in terms of x, we need to eliminate all the x's, all the t's, right? So how do we do that? Suppose we label this with number 1 and number 2 respectively. So from number 1, we can solve actually 5t equals x plus 6, right? That means t is 1/5 times x plus 6, right? And then let's call this number 3. Actually, you can put number 3 into number 2. This will eliminate all the t's, right? So that means y is 9 minus 15 times t. T is 1/5 of x plus 6. As you can see here, there's no t's. They only have two variables, y and x. So in this way, you can find y in terms of x, which is y equals 9 minus 3 times x plus 6. That means y is minus 3x minus 8. Sorry, not minus 8. Yeah, minus 8. Okay, any questions? No? Okay, let's see the next one. Find the value of constant a such that system of equations has infinitely many solutions. Okay, if you want to do this, first we need to solve x or y, right? So first let's try to solve x or y there. So the original system okay, in order to solve the original system, we can use either elimination or substitution method, right? Okay, so let's call this number 1 and this is number 2. From number 1, we can get 4x equals 8 minus 5y, right? That means x is 2 minus 5y over 4, right? So let's call this 3. Then we can put it into number 2. In this way, you will get 10 times 2 minus 5y over 4 equals 5a minus 7 minus 12.5y. Okay, and then from here you can solve y. This means 20 minus 12.5y equals 5a minus 7 minus 12.5y, right? Okay, and then you can put all the y's into the left-hand side of the equation. This will give you 0 times y equals 5a minus 27, right? So from here, you can analyze what the value of a is to make the system has many solutions. So in order to achieve that, the right-hand side must be also 0, right? Because the left-hand side, no matter what value of y is, it's always 0, right? In order to make this equation whole, the right-hand side must be 0. Okay, so that means if 5a minus 27 equals 0, which means a is 27 minus 5. In this case, the system has infinitely many solutions. Okay, have a look at this. Do you have any questions? No? Okay, let's see the last question. Find the value of the constant A such that the system has no solution. Okay, actually this method is the same with the previous one. First of all, we need to solve X or Y. Okay, in order to do this, we can start from the simple equation, which is number 2. Okay, number 2 tells us that for X, okay, let's solve Y in terms of X. 2Y equals 4x minus 3, right? So that means y equals 2x minus 3 over 2. So let's call this number 3. Then we need to put number 3 back into number y. This gives you ax minus 4 times y. Y is 2x minus 3 over 2, right? And this equals 5. So then let's simplify this. This is simplified to ax minus 8x plus minus minus, you will get plus, right? Plus 6 equals 5. So that means a minus 8x equals minus 1. Okay, so your analysis should start from here. So what the value of A should be to make this equation has no solution? You can easily see that if A minus 8 is 0, that means the left-hand side is always 0, no matter what value x is, right? However, on the other hand of the equation, it's not 0. So in that case, there is no solution for x, right? Okay, so if A minus 8 is 0, that means when A is 8, there is no solution. Okay, please have a look at this. Any questions? So after this class, please do spend some time reading my notes, all right? And correct the questions by yourself.